Hello and welcome to another video. In this video we're going to be working on map of highest peak. And in this one you're given an integer matrix is water, that's n by n, and it's a map of land and water cells. And it's a 0 if the cell is water and a 1 if it's land. Or actually the opposite, I guess. So it's 0 if it's land and then 1 if it's water. And then you must assign each cell to a height that follows these rules. The height of each cell must be non-negative. If it's a water cell, its height must be 0. And then two adjacent cells must have an absolute height difference of at most 1. So you have to find something that does that to maximize the height. So obviously, if you didn't have to maximize the height, you could just make all the water 0 and all the land 1, and that would give you a solution. But you're trying to maximize. So here it's like this, and here it's like this. And the main thing to recognize in this problem is you're basically doing like a level traversal. And once you recognize that, really common problem, then you can easily do it. And what I mean here is let's take a look at this example. So essentially, we can just say let me take every water cell, and that's going to be at height 0. And then from there, let me take every cell that those cells appear next to, and that's going to be the second level. So this is like the first level, second level is going to be every cell next to those, so all of these. And then every cell that's next to the second level will be the third level. And I just keep doing that until I traverse the whole thing. So then, in the solution, basically, the first level will be 0, the second level will be 1, and then the third level will be 2. And that's as easy as it gets. So essentially, you basically do a multi-start BFS, where you just put all the water cells in the BFS, and then you just traverse level by level by level. Every time you get to a new node, you just take that node's level is going to be the node that you got there from plus 1. And that's basically going to be it. So you can try this in a big matrix and so on. Just to give you a quick example, let's say this was bigger. So what would happen here is, let's say this is a water cell. Let's make this a little bit bigger. Yeah, so let's say this is a water cell, this is a water cell, this is a water cell, something like this. Let's say these are all water cells. So these would all be level 0. Then every cell next to those would be level 1. So basically it would be 1, 1, 1, 1, 1. And the BFS basically just gives you this. So yes, this is all level 1. This is not. You don't include diagonals. Okay, I think that's it. Yeah, and then everything that's next to level 1s would be level 2. So 2, 2, 2, 2, 2, 2, 2. And then for a bigger matrix, it would take longer to fan out. But essentially, you just basically keep doing this, and then this is how you fill out your result. So yeah, basically going to do a BFS, take every single water cell, put it in, make that level 0, and just do a basic BFS traversal. And once you recognize that this is what you need to do, you should be able to code a BFS like this in 5 to 10 minutes, I'd say. Because it's 70 or 80% of the code is exactly the same, so just whatever language you're comfortable doing that in. So essentially, in every single problem that's going to have a matrix, you're going to have rows and columns. And then you'll have a directions array depending on where you can go. So in this case, we can only go up, down, left, right. So this is going to be the same for all of these problems as well. Basically just a 2D array. And you're just going to have 1, 0, 0, 1, negative 1, 0. So this should be, so far, this should be in every single BFS problem pretty much. So just remember the boilerplate, and then you should be able to do this pretty quickly. Then we make a result, which is just basically a copy of our water matrix. So it's going to be a 2D. And this is just language specific. However, you can make a 2D array in whatever language. And then for every single row, we need to make another nested array. So for every single row, let's make another array in there. For the columns, well, like I said, language specific. Okay. Now you need to make a visited set for every single language as well. You can either do a visited array or visited set or whatever. In Python, you could use visited set and use tuples. In Go, I found out you can also do something like that. So you can basically make a set or a map with Boolean values, and then your key can be just a 2-length array. That's allowed in Go. In most languages, this is not allowed, so you can use like a tuple or string or whatever other thing, or just use a 2D array. So once again, this is all same in every language for every single BFS problem. This is also the same. You make a queue, whatever you want to use. In Go, it's like this. You have to use container list. So essentially, you make a BFS. Then we're going to go through this entire matrix, and if it's a 1, then we're going to add it to our BFS and mark it visited. So this is also the same. So in BFS, you can mark things visited right away, right when they enter the queue, because if you think about it, like in a BFS, things get processed in the same order they were put in, right? So something gets put in and then something gets put in after. This is going to get processed first. So if your cell's already in the queue, you don't need to put it in again. So as soon as you put it in the queue, you can just mark it visited right away. Okay, so we're going to go through this whole matrix. And yeah, this is called like a multi-start BFS. It's very simple. It's just the same exact thing as a 1-node BFS, except you just put in multiple nodes, and then the rest of the code is all the same. So if is water is 1, then that's a water cell. So we're just going to add to the back of our BFS. And so here, this is also very similar for most problems. Usually you have some kind of like a distance and then coordinates. So that's what we're going to do. So we're going to add 3 things. Distance will be 0, which this is our level, and then our coordinates. This is going to be almost the same for every single one of these. And add it to the visited set. So we're going to add row column, and we're going to make it true. So basically, as soon as we add to the BFS, we'll just mark it visited. Now the rest of it is just, while the BFS is true, do some stuff. So all that code is going to be the same as well for every problem. So if you take a look, like after we finish this, I'll kind of show you what lines need to change, but 90% of this is just boilerplate. So you should be able to do it very quickly once you do enough. Okay, so we need to get like the front of the BFS, so we can say like front or cur or something. So this will give us the front element, and we need to remove it. And then, or I guess we can call this front. And then to actually access the value, we need to like basically type change it and like make sure that it has these 3 things. So we can say current equals element. So I think this is like a pointer in this container list thing. It's all language dependent. So essentially we want to get its value, and we want to make sure that we want to let it know that it's like this format. So 3 elements. And now we have access to this like current slice thing. Now we just want to destructure it into 3 things. So we can say like the level, and then the x and y coordinates are current 0, current 1, current 2. Okay. And now we want to set this value in the result. So we can say result at xy equals level. We know we haven't visited because we're only putting things into the queue once, so we're good there. Okay, so now we have to go through all of the directions. And this is language dependent again, but this is going to be the same for all BFS problems. Essentially, go through all the directions, so we can just say like for we just want to get the value in range directions. Call this like dir. And then we want to get the xy in here, so we can say, or we can just say like new row, new column is x plus direction 0, y plus direction 1. So essentially try all 4 directions, up, down, left, right. And then we want to make sure we're not out of bounds. So if new row is less than 0, or new row is equal to rows. For a BFS, you can never be greater than rows, because you're going to go from rows -1 to rows, and you're only traversing like one cell at a time. So you don't need to check greater, but you can if you want to. And then this is just equal to columns, or if we're visited. So if we're visited, we don't want to do anything either. So new new column. Okay, so essentially, if we're out of bounds or visited, just move on. And then, so like I said, as soon as we're putting something into the BFS, we can mark it visited right away. So visited, yeah. Column is true. And add it to the BFS. So we're going to add a array of 3 elements. It's going to be our old level plus 1, because it's basically a level traversal, and the row column. Then once we're done, we can just return result here. Okay. So kind of a pain in Go, but in other languages it's easier. So let's see what errors we got. Unexpected new line. Okay. I mean, I can just do this, I guess. Or put like a comma in or something. Okay. This needs to be this. Okay, let's see here. Unexpected type. So, oh yeah, we didn't give it a type. All right, one more, I think. Yeah, same. Okay. Defined element, this is front. Define num. This is level. Okay. All right, there we go. So yeah, I'd say goals, preparing for interviews for this one. Yeah, I'm not sure why this ends up being slow compared to other problems. Like, this is still like the optimal solution basically. So maybe there's like, I guess there's like a DP solution. Maybe it runs faster or something. I don't know. But essentially, yeah, you should be able to figure out, like from here, I'd say like what you should do in roughly 10 minutes. And then you should be able to code it in roughly 10 minutes, I'd say. Because this is all boilerplate. Like this result might be different, you know, depending, but yeah, like this is all boilerplate, this is all boilerplate, adding things to your BFS is all boilerplate, and then checking while the BFS is also boilerplate, you get some stuff from it, and then you go through all the children essentially, or all the nodes next to it. So if you compare your code for like BFS matrix problems, yeah, like 90% of it's gonna be the same. So just little small tweaks to do whatever you need. And runtime here. This is going to be mn, typical BFS, and space is mn because we have the visited set. So yeah, it's going to be all for this one. Hopefully you enjoyed it. Hopefully you understand how to like have a BFS template and stuff. And yeah, that's going to be all for this one. If you liked it, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.